Water is essential for life. It is used to make every product on Earth. Agriculture by far consumes around 70% of water than any other source, and wastes much of that through inefficiencies. Meanwhile, the palm oil industry is one of the key economic drivers of the agricultural sector in developing countries. Indonesia and Malaysia produce about 85% of the world palm oil. Commonly, a rapid increase in production process would result in significant environmental pollution. For every metric ton of palm oil produced, 2.5 metric tons of effluent are generated. Direct release of this effluent can cause freshwater pollution, which affects downstream biodiversity and people. In 2002, at Johannesburg World Summit on Sustainable Development, countries were required to develop Integrated Water Resource Management (IWRM) by 2005 in order to reverse the current trend in water resources degradation. IWRM is a process which promotes the coordinated development and management of water, land, and related resources in order to maximize economic and social welfare in an equitable manner. Let's see an example of how things are done today and how they could be improved with the implementation of IWRM. The processing of oil palm fresh fruit bunches (FFB), primarily for palm oil, requires a lot of water. Fresh water is taken from the nearby river to be used in the processing of palm oil in mills. Consequently, palm oil mill effluent (POME) are generated from the processing of the palm oil in the mills. By using conventional methods such as ponding system and extended aeration system, the POME is not properly treated and is disposed of further downstream. With this approach, rivers and air have been polluted and resources have been wasted, making this practice not sustainable in the long term. But there is another way. With the implementation of IWRM, the POME can be treated to produce clean water and reused in the processing of palm oil. The POME is collected in digester tank in which the organic material is digested, combined with a system to collect and store the biogas produced. The biogas captured can generate electricity for their own use at the mills. The sludge removed from the settlement undergoes further treatment and is then provided to farmers to use as a natural fertilizer. Algae is used for the next process in POME treatment in order to reduce both chemical and biochemical oxygen demand. The supernatant liquid can be filtered and then disinfected, which results in clean water. With this practice, water has been reused. So, what's the problem? Well, there's going to be some challenges that need to be faced in the implementation of IWRM. There is a number of polluters that are not able to comply with the existing effluent discharge standards. This problem can be overcome by applying polluter pays principle, and the state government should obligate palm oil mills to comply with much stricter discharge standards than those already imposed by federal government. Another challenge is that there are companies that greatly prioritize profits rather than making an investment for the implementation of IWRM, even though they are aware about this matter. Therefore, the Department of Environment (DOE) must enact laws and regulations that all palm oil mills in Malaysia need to be equipped with a closed anaerobic tank digester as well as biogas capture facilities. Apart from that, the technology in Malaysia and Indonesia is still underdeveloped in contrast with those of other countries. To combat this, outside technology should be utilized, and the government can assist in reducing the costs associated with the importation of this technology by tax reduction. By implementing IWRM, many different uses of finite resources are interdependent. Water recycling is reusing treated wastewater and can be tailored to meet water quality requirement, which offers resource and financial saving. Using water resource can satisfy most water demand, thus decrease the percentage for water use in agriculture sector. Based on its synergy, it has met the objective of managing the quantity, quality, and reliability of nation's water resources.